Hello everyone, let's wait a few more minutes until everyone joins us, then we can start. By that time I will share all the materials needed for today's session. Okay, I think we can start. Hello everyone, welcome to today's session, and as you can see we have lots of topics to discuss today. We'll finish the practical assignment we started last time, and then we'll have one more practical assignment. I also shared with you this small one, and after that we'll go back to theory, because there are some more things to discuss regarding object-oriented programming. So there are lots of things to discuss. There's a question from Willie regarding overriding. As you can see, overriding is also the part of the topics for today's session. So we'll discuss it. It's related to inheritance, so we will discuss it as a part of inheritance, and this is mostly related to inheritance, so I'll copy this one. Yeah, that should be correct. Okay, so let's move. Let's finish our. One more thing I would like to mention about the home task I sent you last time. So I think we better move it to next Friday, not Monday, because today we'll discuss some topics which will help you to implement your home task. And that's why let's move it to next Friday. It's 22nd of January. Because on Wednesday, as you remember, next Wednesday you have a workshop, as you can see in the calendar. So that's why next week we'll meet on Monday and Friday, and let's move home task for next Friday. So I will share it with you again, just those who missed it last time. So I will share it now again with you. So that will be for next Friday, 22nd of January. Okay, so now we are ready to move on with the assignment 2 from the file. So last time, as you remember, we finished with calculating average level in district. Total officers summarized and divided by amount of officers in district. So I think that was this method. Average. Sorry, I think we did not divide it by the number of sorry, I accidentally closed the file. So we forgot to divide it. So to get the average, we need to divide by the number of officers. So that's why let's divide it. To divide it, we can use officers variable, and here we can use the method size, which will, as you can see, we already used it before, which will get the number of elements in the collection. As it stated in the agenda, we will also have a small overview of array list type, since we use it right here, as you can see. So we will shortly, I will shortly explain you again what does it mean and how to use it. Okay, so right now we implemented this point. Yeah, average level is calculated. Okay, so and the last point is that we need to create new class with the main method late. Okay, I will create new class and I will call this class as execution class. Okay, just execution. And yeah, so we need main method here as it states from the requirement. Yeah, and then we need to create 7 officers as the objects and 2 districts as the objects. Okay, so we can create, it states that we need to create 7 officers. So since I'm lazy and I don't want to write a lot of code, I can use again array list, or I can use it to be more simple for you. I can use just simple array officer, then I will use officers, and then I will create the array. There will be, so since we need 7 officers, there will be 7 elements inside the array. Officers as the objects. Okay, so and right now in the cycle we can initialize, just create all these officers. So okay, instance 7 and I plus plus. So here I will put the officer. And I will create a new officer. So, yeah. And we need to also create 2 districts. Yeah, 2 districts. Okay. Yeah, so I will declare all the variables on the top. So that's also an approach which is commonly used in different programming languages. That the style is that we mostly define the variables on the top. Sometimes that will be easier to search for the place where the variable is declared in case we need to do any changes. That's why I'll put the variables on the top. And here again I will create 2 districts, the same way as created officers. And districts. So we yes, that's correct. And 2 districts. So since there are just 2 districts, I won't use the loop. I will find districts in the following way. District 1 plus new district, and I think yeah, we need to provide all the parameters. Title would be called district 51, and the city would be New York. And district ID would be 12. Yeah. The same way we can create the second district. District 21, the Washington, 22, for example. Yeah, here I don't use the arrays because array list. The array list because I actually know the how many elements will I have in the arrays, so I don't need to use array list because again number of the elements are fixed, is fixed. Yeah. So I don't need to use array lists. If I don't know how many elements there are in the array, I will use then the array list. Okay, so now let's add both districts to the array. Or not, it is not required, I guess, in the task. Okay, I'll print out, and in case I need it, I will print. I will comment it back. I'll comment here. I commented out, but in case I need it in future, I'll just comment it back, since it is not required us to add districts in the arrays. Okay, so now we need to add 3 officers in the first district and others in the second district. Okay, so here I can use again the cycle. First 3, and then I will add them to the first district. And so here I call the method add new officer from district object, and now I need to provide the officer, and I can get the officer from the array. Officers from the array. So here I did, and in the same way for the second district, I start at 3, and then until 7, and then add to the second district. So yeah, now I edit, and the point is done. Then the next one is print out all information about each district. Okay, so I will district 1, system out, sorry. And 2. Okay, let's check have I override it to string method. Yeah, I override it. Number 3, that's mentioned in the task. 3 officer. Not that 3 officer. Yeah. So here it's mentioned, and 3 officers in the first district and others in the second district. And it's taken from the task. So yeah, here's the information. Unfortunately, I have not provided any names for any officers. That's why I get no. But I hope. But yeah, if I create 7 officers, for all of them I can provide the information, and then the corresponding output will be here. But since I haven't provided, so I just have all the empty values. Yeah. Why do I have so many? Okay, I have the title, I have the first district, here is it. And why do I have so many information? Okay, let's check. So the city comes from here, then I have district ID, and I have officers in district. Oh, okay, so that's yeah, okay, that's because I just printed all the officers in district. Okay, let me check, was it required from the last time or not? Okay, yeah, so here's the issue. And that's because I just printed all the officers in district. So as you remember, last time we created a string, and I provided this information and I wanted to find how many officers there are in this string, but I accidentally forgot to call the method size, and this returned as just the object of the objects of the officers, not the size. If I use the size, then I will get correct result. Okay, just it's also and one line separator as well, since just to distinguish. Just a line separator and to distinguish both districts. And let's see what do we right now everything seems to be fine. So yeah, it shows the title of the district, then the city, district ID, and the number of officers in the district. Okay, and also I forgot to put name officers, so let's quickly solve it. Officers in district. So I missed this word. So right now I edit it, and the information is correct. Okay, so then the point is done. C point. Then let's go to the next point. Remove one officer from the second district. Okay, let's remove one officer from the second district. Since it is not mentioned to which officer should be removed, then I will just remove the last one. So I will call the method remove officer, and I will provide just the last officer from the array. Officer from the array. So this will remove this officer, the sixth created in the cycle. Okay, that's done. And calculate, and now let's calculate average level in each district. System out print 1 each level plus district 1. Now in first district, in the first district 1, calculate average level. This would be, and this would be, and the second one. So I line up line separated just to distinguish the information. And same for the second district as for the first one. To calculate average district. And so it's 1 because I just haven't provided any information. You can try it yourself. You can add some information to these officers, and then you will get meaningful results. Okay, so and then in point F it states that we need to take a look on array list class. As I said, basically we already used it, but I will mention it after this after we finish this one. And so it also states that we need to create array lists, but basically we already created array lists. So this one is done, and now we can calculate how many officers are in both districts. So we can quickly calculate it. One. There are. I will use district 1. I will ask for the officers in district. So this returns me the array list, and I will just call the method size. Officers in the first district. And the same for the second one. There are changing the object and I'm changing the text as well. So this, so there are 3 officers in each district. That's because we removed 1 officer from the second district. If we comment it out, we'll see that in the second district we should have 4 officers. So the method works correctly. And yeah, number I is point I, calculate the average level of both districts. The next one, right? So previous point is done. And the next one is calculate average level of both districts. So what we can do, yeah, so we can actually add maybe just to make it more clear, let's just fetch the array lists from both districts. So we'll have array lists of officers, and then officers in the first district. And I will ask the first district to get officers. And the same is for the second district. So now I will have the array lists here, and then we can create a common district. Yeah, common district. District. And the title would be District 1, for example. Then the city would be London, and the district ID would be something like 323, for example. And what can I do? I can actually add a new collection of the officers, and I will do it this way. Let's start with the first district. So we can add collection to the collection. So we can add the array list to the array list. It means that we just concatenate, unify the elements from both arrays into one. We just add new elements in the array list. And the same way we can do it for the second district. Get officers, add all, and I will add the officers from the second district. And now we can calculate the average level. So the result should be 1 again, because the officers are the same, but just to make it sure that all the elements are added to this new district, I will also print how many officers there are in the common district. So comment district. I use get officers and I use size. And in common district. So then we'll see that there should be 7 elements because we just added the 6 elements, I say, because we removed 1. So we add 3 elements from the first district. Then we added the other 3 elements, other 3 officers from the second district. So yeah, that's it about this point I. And we have 2 remaining points. Find out which district is the best based on the average level of officers. Yeah, in this case again we have empty officers with no information. That's why we'll have the same results. Again, I will not populate all these officers. You can check it at home. Already at home. I mean, as your in addition, to what we do here. But I will just provide the logic which will help, which can do it, and just to test it, you can create your own examples with the officers. I mean, so in this case again, we populate just empty officers here with no information. I will write the comment. Create empty officers with no information. To test, fully test the logic here. Test the logic. You can create the officers with the information about them. So then you will have different calculations. But here I will implement the logic for J point. So find out which district is based on the average of officers. So again, I will I will just simply use this method, and I will do it this way. I will use system out print 1 and so I will do it this way. I'll have if statement, and then I will compare if they're the same. So if both districts have the same level, then I will print that levels are the same. Otherwise, I will do it this way. I'll print and I will add the Boolean comparison. So I will check it this way, and then I will do it this way. So we have Boolean, and here I check if true or false. So if true, then so this is true. Then district 2 has the inspector level, average level, else district 1 has better level. And we'll close the statement. So remember that this logic works in the way that here is the Boolean, and this returns Boolean. We have 2 integer values which are checked, and if this statement is true, so here we check if true, then this one is returned. If false, then this one is returned. In this case, we'll have that the levels are the same, because again I have just empty officers. If you if you do some adjustments with the officers, then the result may be the same. Then it shows delete the first district. Delete the first district. To be honest, I'm not sure what does it really mean. Delete the first district. To be honest, at this point is a little bit crazy, because we cannot actually delete the object. Yeah, it is not possible. To be honest, I'm not sure what it is really mentioned in this point, because we cannot delete the object itself. Or we can just remove it from the code. Yeah, maybe we'll skip this point. I'll try to think what is really required here, because we cannot actually delete the object. Okay, so we'll skip the last point here. It seems a little bit crazy, but yeah, in the overall we have done this task. Okay, if you have any questions about this task, please ask. If not, then so I will change the agenda a little bit for today, because as we have lot of topics to discuss today. So I will at the moment I'll postpone this assignment. So maybe we will take it once we finish all these topics, because these topics are really important, and you will need them in your next home task. And that's why we'll postpone this a little bit, for a short time, and we'll go back if we have time. But right now, let's move to the theory. Because yeah, we need it a lot here. Okay, first of all, let's shortly talk again about array lists, because we haven't discussed them before, but we actually use them. So I will create one new package here. And then here we can quickly discuss one example. Okay, so basically, what was the motivation for us to use array lists? In case, for the simple arrays, we don't know, as I said, we don't know how many elements there can be inside them. So that's why for the arrays, if we want to use the arrays, we need to provide the type. So in this case, if I create, for example, integer array. So if I create integer array, I cannot just simply create it without providing the dimensions. So I will create a comment, cannot be created without providing the number of the elements. So in this case, we don't know how many elements there are. But just in case we must use something like that, if we have some logic which uses unknown number of integers, for example, what should we do in this case? And just to store all the integers, we can use store unknown number of integers. We can use array list. Not only integers, but any type. But in this case, we'll store integers, and so we have these comparison marks in brackets, and this thing is called generic. We will not talk about generics in this course, in introduction course, but this will be included in the next Java course, which is more detailed course. So basically, it means that here we provide the type for the array list. Yeah. So inside these comparison marks, we need to provide the type. So I will provide integer. I provide integer, and I will provide the variable name, the same as for all the variables, and I will create the array list. So to create the array list, we need to create it the same way as we create the objects. And what do we see here? Maybe I will write above, just for you to make it more understandable. So first of all, let's we have again the type. Array list. That's the type. As for all the objects, for the objects and all the variables in Java, we provide the type first, and then so we provide integer. Yeah. So it means that that only integers can be stored in this array list. So we cannot add array list. We cannot add the string to this array list. So I'll comment it here, since we defined integer. I think in this way, so that would be more understandable for you. Find integer as the type of the elements to be stored in the array list. We cannot store the elements with a different type, with other types. Only integers. Only integers. So that's what we say here. And basically, for all the not proper classes, for all the generics, when you see the class which requires you to provide something inside these comparison marks, you actually need to provide some types, to these parameters. So in this case, array lists has one parameter. We provided, if we talk about some more types, like about maps, then in map class there are two parameters provided, so there can be multiple parameters in such classes. But all these parameters mean that there's actually the class. Inside the class, this class uses some types, some unknown types. These types may be different, and just to specify it for the compiler, to make it more understandable to read, to not allow any mistakes, generics are used, and in this case it says that the type is not just any unknown type, but the type is integer. So by okay, maybe I will tell it now. So if we have if we have array list object, so this can I'll tap it right here, and then we'll see why when we talk about the inheritance, and we will see why this thing works. So if we provide object as the type of the array list. It means that all the types of the elements can be stored in the array list. So we'll see why, but that's just a small remark. If we use object, we can provide any type here. But that's also that you'll see why it is so, why it is correct, and why it will always work, because that's related to inheritance. And we'll talk about it today. And the last thing here, just on the declaration, is that we cannot define array list this way. Array list integer, because only reference types can be provided to the array in the array list. Only reference types. So I will type here primitives cannot be used as the types of the elements in array lists. And just maybe a small remark. This is true. I mean, we cannot provide primitive types for all the cases, all the classes, because again array list, that's also the class. If we go to the declaration, you can see that that's also the class. So that's, I mean, as you remember, all the reference types are classes. So array list is the class as well. So, and the remark is that we cannot provide primitive types for all the classes, in all the cases, or all the classes where generics, these are generics, I mean types provided in the brackets, in the comparison marks, generics are used. So when you see the class which uses generics, generic types, these comparison marks, where you need to provide the type. Again, as I mentioned here, you need to provide the types to these generics, and you can provide only the reference types. You cannot provide primitive. Not for lists, not for any other collections, not for any other classes. Only reference types. But that should not be the problem for us, because again, instead of primitive integer, we can use a wrapper class of integer, and this will actually solve the problem. So I think that's it about the declaration. So we discussed the declaration. To create new array list, you need to create the object. So I can create the same as for all the objects. And I need to create the object. that's why we call new here. Alright, so we are finished with decoration, and right now we can move to some properties. So since we have integers, we can add integers. So we can add as many integers as we want. As many integers as we want. Yeah. Comparing to the arrays, just simple arrays, where we cannot add more elements that defined inside the brackets. So yeah, that's how to add. Yeah, just simply call the method add and provide the integer number, provide the element. So yeah, you can also call the method add. Okay, maybe what add at index. So maybe let's add some more elements. 1, 2, 3, 4. And also okay, I will create the method to print the area list. Static void print area list. So I will create this function like this. Want to print the element, all the elements. In this case, okay, I'll use integer again. And so what we can do, actually, yeah, we have two options to iterate. So here we'll see how to iterate through the iterate through the array list. There are two options. First one, simple option, we already used using for loop. So what we can do, we can simply use for int I equals 0, then we get the size of the list and we increment I, and then we will print, system out, print, and here I will print the element. So I will use get. And using get I can get the element positioned at index I. Okay, for the condition. Using get I method, we can get the element which position is positioned at index I. Okay. Using get, and now we can print it. Okay, so just quickly to see how it works, I will call the method print array and I will provide the array list here. So we will see that this one should work. All the elements are printed. Yeah. That's the simple way, but actually this is not how we usually iterate to the collections. So not only array list, but all the collections. That won't be incorrect if you do it, so that's also fine, but there is one way which is used more, and it is called using iterator. I can call default option for the collections. And how does it work? So first of all, we can get iterator object from the list. So we use the interface. I haven't told you about interfaces, but we'll talk about the interfaces today. And so maybe not today, but maybe on Wednesday. Let's see how it goes for us. Implementation works a different in strange way. Exactly in strange way, but okay. So here we can use iterator as the type. Actually, that's the interface, but interfaces can also be used as the types. So here we use the iterator, and for the iterator we need to provide the type as well. So again, that's the integer, and we declare a new variable, called iterator, and from the array list we can get iterator. A variable, and get the iterator from the array list. So we got iterator here, and now we can go through the collection, through the list. And how we do it? We use while cycle, and we check one thing, and the thing is has next. So okay, I'm not going to do that here. So if there is the next element in the list, as next will return true. This will help you understand. And basically, what does it mean? It means that we have the list, so it means that we have all the elements stored just one by one. So I type here the list elements stored one by one. So we add the first element, so there will be the first element. So I'll type here. So the list will look like that. Here. So this will be 4343, first element, then there's the second element, 42, this element, and so on. So just one by one, stored. And using the iterator, we go through them, starting at first element. No, actually, no, we don't start at first element, we start at 0 element. So before we actually start, it calls the method has next. Then if it checks if there's the next element on the right, so we are right here somewhere before the first element, it checks if there's the next element, it checks, yes, there's the element here, so that's true, and we'll go inside. And here we can print out next element, and to get the next element we use next. So using iterator next, we can get the next element, and the result will be the same. So I will comment this one just to not interfere, and to see that this will print us all the elements in the same way. So using iterator. Again, there are basically no differences from the point of view, but yeah, there's less things you need to declare, so you don't need to declare all these cycles, all these parameters of simple for loop. In this case, we just use the methods has next, which has next, and then next, which return as correct information. Alright, so yeah, well, now let's have the break, and after the break we will finish talk about arrays. Okay, let's have 10 minutes break now. Okay, let's move on with the array lists. So yeah, we have add method, then we can get iterator, we can iterate through the elements, we can get, we can use get method, we can get corresponding element by providing the index, and so I hope you understand that that's if we have elements one by one, that the index is, so that's the index 0, that's index 1, index 2, and so on. So they are indexed in the same way as we add them to the collection. So if we add this way, so this will be the first element, the 0 element, this will be the second element, and the first element, sorry, element 1, yeah, element 2, element 3, and so on. So we just add them, and they are located by the position at which we added. There's also one method today I mentioned, but haven't used. Also, we can add, but this is add, and we provide the position. So, for example, if we provide the second position, and we add the element. And then we print, and I will comment it here. I'll just simply, no, I will comment out, and then I will print it this way. Here, yeah, this one. Then I'll print, and what we can see at position 2, position 3, and at index 2. It added another element. Yeah, so if we have elements 1, 2, 3, 4, if we type add, then we provide the position. This will add another element in between the positions 1 and positions previously 3. Now it will be 4. So. And adds the element, the positions between the elements. Elements located at the positions. Okay, the positions would be 2 and 3. So in between them, we have a new element. So that's what we can be using at index and the element. Yeah. So what else do we have? Add all. As you remember, add all means that we add new collection. So I'll just take it this way. I'll comment it out. I will not create another collection, but we already used it. So I'll type it. And so here, as the argument, we provide another collection, another list, array list. list, and basically with the elements and with the integers. And then all these elements will be added to the array list. And we already used it today, so I will please check the usage so yeah, we used it here. No, maybe I'll tap this way. Assignment. And the class name is execution. Yeah, here. And we used it today. So I'll just put the reference here. Yeah, so please check how it is used here. So that's method add all. What else do we have? Add all clear means that all the elements are deleted from the list. So there's nothing special. Contains returns true or false. Yeah. Returns true. Okay, actually we can check it directly. Why not? I will use system out and system out and line. And it actually checks if the corresponding element exists in the collection. Oh, sorry, this one. Okay, so this will be true because the element 1 exists in the collection. Checks if the element 1 exists in the list. And if we type something like system out print element 2, and if element 2 exists, if array list contains element 2, then this will be false, because there is no such element added to the collection, to the list. Yeah, so if we run it, you can see that this will be false. Okay. Clear clone, that's a different method. Clone that's specific for all the objects. We will not talk about it now. Contains all. Checks all the elements. Yeah. Checks if there are multiple elements. Collection in the list. What else do we have? Yeah, I can remove like the corresponding index. And for example, like remove 3. This will remove the element position at index 3. So what else? Remove equals, that's comparison. That's not important for us. For each, that's part of so-called functional programming. We'll not discuss it in our case, because that's also an additional additional way how we can iterate through the elements, but for us that's enough to use iterator or just simple loop using get method hashcode. That specific thing for all the objects. Index of if we provide the object, and this will return us the index if such element exists in the collection. As you can see in definition, if such element does not exist, then the index -1 will be added. Empty checks if the collection is empty or not. Iterator, we know. Last index, last iterator, that's different thing, but similar thing to the iterator. All these elements are come from the object class. That's different element. That's the methods which come for all the objects. The stream for the collection, that's not really interesting for us. Remove, as you know, yeah. Can remove the elements, remove all. Size, as we already discussed, that returns the size. We can use sort, but it's not maybe so specific for us. And basically, yes, I think to array, if we want to convert it to array at some specific point, why not? But yeah, so we already discussed all the main elements which are mostly used for the collections, for the lists, yeah, not for all the collections, but mostly for the lists. So yeah, right now we discussed all the main things for the lists. So you can use array lists with all the beauties of this functionality array lists provide. Yeah, so if you have any questions about array lists, please let me know. If there's something I missed or you don't understand about the array lists. But right now let's move on by agenda, because we have more theory about object-oriented programming. So yeah, there's lots of things to discuss. So let's move on with polymorphism. So that's the quick intro without the presentation. I will quickly explain you the main idea of polymorphism, as it comes basically from biology. But in the programming we use polymorphism term as the term to describe in object-oriented programming, to describe the situation when we have multiple objects, different objects, different classes, and basically just as the overall explanation, it means that one object, basically the variable with one specific type, can actually have the value from the different class. So if we have one variable with one class, then we can assign the value from the object which comes from different class. So basically it means that one class can be used as the part of different classes. So we can assign one type of object to other types of the objects, other types of the variables. So that's a short introduction. We will basically see what does it mean when we just go step by step. And the main thing is in object-oriented programming, also Yeah, that's how the polymorphism works. That's inheritance. And to discuss inheritance, we will open the file. So let me open this PDF file. Inheritance. And starting at slide 9. Slide 9. Okay, so here it is. 25th. So yeah, that's the start of polymorphism, and that's by now we know that we have the classes. From the using the classes, we can create the objects. So that's what we know right now. That's the key part of object-oriented programming. We have the references. Yeah, each object does have the reference. So based on these references, we can access the memory and the specific place in the memory where our values of the object are stored. So right now, by this moment, we created different objects, and then we called the methods from these objects, changed the attributes, used the attributes, and so on. But that's not all the things which can be done using object-oriented programming. And basically, this object-oriented programming is not only the class definition and just using the objects. In addition to what we already discussed about the classes and the objects, there are more things. And when we start talking, and basically these more things are a part of polymorphism. And we start talking about polymorphism using the topic inheritance. So basically what it is and where it is used. So as an option, we are making, as an example, we are making the game, and we have public class dude. Then, as the attributes, we have the name, we have some integer, some properties. So then we have the methods same name, punch face, and then we just have some actions here. But so then if we want to create the class wizard, so what we need to do, by the information we know so far, we will need to just copy paste the object from one class to another. That's basically not what we actually want. Yeah. But again, the wizard does have, and basically it has everything what Jude class does and has. So basically, that we don't need to copy paste. We can use the wizard as the subclass of Jude. And so using this one, we can extend the class Jude and create the class wizard. So as maybe more understandable example, I will show you the following example. So maybe let's start with the creation of the package. And the most, just maybe for in our case, most simple example would be the class person. So we have the class person, and then imagine we need to create three classes: the person, then the employee, and then the CO, for example. So we have person, but we understand that the employee and the CO, they both are the persons as well. So in this case, we don't need just to write the same code 3 times. So what we can do, we can create the person class, Then using the person class we can define the name, surname for example. Let's define the name, string, name, define it this way, name, surname, and integer age. Okay. So I will write comment. We want to use all these properties. These in the class says director, let me see all, and employee, because they both are the persons. Yeah. So in this case, so there are the properties, and what we can do, we can create new classes. So the first class would be employee, and that's my mistake. Let's not use the private. So that would be the first time we use protected. Protected. I will explain why we use protected here. And what we can do here. So here we have now the class employee. I want to extend, basically I want to define that employee is also the person. So what I do, I use the keyword extends, and I type the class person. So now we define that employee is also the person. So that's what we define. And basically what we see, if we have the method here, what would be what the employee may do. Maybe get salary, for example, public. It can be public void get salary. Then in this inside this void we can see that we actually have the elements age. So maybe there's the method which asks to calculate salary, so we can maybe let's add one more parameter, experience, years of experience. No, maybe let's add qualification for employee. Let's define as qualification. So, qualification level. And so we can move. And for example, we can do it this way, that salary. Okay, maybe let's just return here. Return the salary here. So we can return, and what we see here, again, as I already mentioned, we can use age, which comes from just simple primitive calculation, and we can see that age attribute is also the part of the current object. we haven't defined it here, but it actually comes from the person class. H variable comes from person class. Here it is defined, and that's why we define it protected. So in case we define it private, so I will define for example as private, and we will see that this will not work. Yeah, we cannot use it private. Cannot use as private because it won't be available in the subclass there. Since then, yeah. So in this case, we cannot use it, but we can use protected. So if we use protected, we use protected with the access modifier where the variable will be visible, available. Let's call it this way. No, it's available for the subclasses of the class person. Yeah. So if we define it protected, then the variable will be available here. If we define it as private, it won't be available. Yeah, all the other properties are mostly the same as for private. Yeah, if we have another class in different package, then we cannot access protected attribute. The same as the private attributes. All the other properties, these are mostly the same as for the private attributes. So that's basically the key usage for protected access modifiers. Yeah, we previously haven't used them because we haven't used the subclasses. Since right now we started looking at inheritance topic, then we can see that we use subclasses, and then we need to inherit the attributes from the superclass. And yeah, about the terms, if we have the class which is extended somewhere, then this is the superclass of class employee. And if there's the classes which extend the class person, then it means that class employee is the subclass of the class person. In Java, we can have only one superclass for each class, but each class can have multiple subclasses, and that's basically what we will see right now. Yeah, if we create the class CO, then let me the CO gets dividends, for example. Public integer get dividends. And yeah, so since this is the what else do we have? Yeah, so the first the CO can get dividends, and maybe let's add calculation based on age. again age times 1000, for example. Yeah, so again, since we haven't provided the superclass, we will not see any parameters, obviously, but if we provide the superclass, then we can see that the person is available, or that the age is available now, which comes from the person clause. Yeah, so that's the thing about the inheritance of the attributes. So if we define them as protected or public, so maybe let's just quickly have one example. Public, let me years of experience. Years of position. Then and if we add it here, then we will also see that public attributes are available as well here. Okay, so we can see that that here. Public and protected attributes from the class person will be available in this class. So the same for the public, that works the same as for the protected. All the attributes are here, protected and public. So this is about the attributes. If the attributes are defined in superclass, then they will be available in the subclasses. And also here, one class can have multiple subclasses, but each class can have only one superclass. No way that we can extend from more than one class. So this is about the attributes. So we define them. Private attributes will not be available for the subclasses. But that's about the attributes, and then we go to the methods. And for the methods, this will be more interesting than for the attributes. For example, what we can do, we can create the method public method, or protected method, okay, let it be public, and describe person, public, and describe person. And here we can print out the name, then I'll just tag them in the same line. Let's use the line separator. Then name, I will type surname, okay, the page, age, and the last one I will also type the years at the position. This years at the position. Need the one separate the last one. Yeah. So yeah, now we have the method, which is defined in the superclass. Yeah, how we can use it in the subclasses, and basically it can be used in the subclasses. We can create the method. Maybe let's create the main method here. Create the main method here, and then I will not use CO at the moment. I'll just use it as a separate class, but right now let's just use an employee class. So what we can do, we can create employee object again, not again, but the same way as we do for all the objects. We create the object, call the constructor, create an employee, and as we can see that from the employee object we can access, we can call the method. The method is describe. Right? So method which comes from the superclass person. So and now we can see that. Okay, maybe let's use the constructor. Same about the constructors. We have the constructor, and we can provide the information about the person. So we provide the name, surname, age, and yeah, maybe let's not use here as the position because that's not related to the person directly. Just to be more precise, let's skip this year's position. No, skip it. Skip it. What's the issue here? Oh yeah, that's the constructor. We'll see why there's the error. So there is the constructor, where we can provide the same as for all the classes. We can provide the attributes. And what we will do here, we will provide the attributes. So the name is name, then the surname is surname, and the age is age. We already did it this way. So, and what is the error here? The error here is that actually the constructors, the methods are also inherited. So what does it mean? Firstly, all the public and protected methods, the same as the attributes, they are inherited in the subclasses. So in the subclass you will see you can use all the protected and public methods which come from the superclass. And the same is for the constructor. We can use constructors from the superclass in the subclasses as well. Yeah. But so again, as you know, that constructors work in a little bit different way than just simple methods because, as you remember, constructors will be called every time when the object is created. So when you create the object, then the constructor is called. So at this point, it comes a little bit, I wouldn't say crazy, but in maybe more tricky way than for the methods, because again the constructors must be called, and since we define for the superclass constructor which has multiple parameters, then as you remember for the not multiple, but basically the parameters and at least one parameter or more, then for the as you remember for just the classes, every class if there is constructor defined with the arguments, yeah, as we remember we had with district, it means that we cannot create the class without providing the object without providing the parameters to it. Yeah. So maybe I will also type the comment here. If the arguments are defined for the constructor, we cannot create the object without providing them. Yeah, so that's just for all the classes. That's what goes for all the classes, and the same is for the super classes and subclass for the superclass. Yeah. And so basically, what does it mean? We have so what's the situation we have right now? We have the constructor which has the parameters in the superclass. So it means that the superclass cannot be created. This class, superclass, cannot be created without providing these parameters. But basically the idea is that when we create the subclass, then the constructor of the superclass will also be called. Will also be executed. So in this case, the situation is that without defining the constructor employee, we cannot create the object. So that's the first point. First point, the object employee cannot be created without if not only the object, the employee class cannot exist. The class cannot exist, cannot be compiled if the constructor is not defined. It's not defined because we only have parameterized constructor in the superclass. And that's the first point. But we have a second point. We still have the error. And what the error is, all the constructors from the superclass, not all the constructors, not all the constructors, the constructor, one constructor from the superclass must be called. And this, what comes here? As you can see, the error is that it shows that there is no constructor person without the parameters defined. And by default, automatically, it calls the constructor from the superclass automatically. Yeah, if we create the object of subclass employee, the constructor of the superclass will also be called. But since we don't provide any parameters and we have just the constructor with the parameters, the superclass, that means that there's the only constructor we can execute, and this constructor is this one, super. That's basic, and here I will also provide the parameters. Let's provide the parameters. So here I need copy paste. There is no other way. And yeah, so now I have the constructor employee, and the last thing I need to do, I need to call the constructor from the superclass. To call the constructor from the superclass, we need to write super, then the circle brackets, and inside these brackets we can provide the parameters. So yeah, and that's it. This is how we call the constructor in the superclass, how we access the constructor in the superclass. Using super, then we provide the parameters. And what we have, here we need to provide these parameters if we create the object. So, let's provide name, be Trump, employee, age is 70 years old, something like that. And then we can call the method. So we are here. Employee. We can run the method employee. Oh yeah, that's the errors in the project, but that's not the issue for us. So here's the method describe, which is called here. So this method from the superclass is called. So we accessed the object employee, which is class employee, but we call the method, which is defined in the class person, because the person is the superclass of the class employee. So all the methods and all the public methods are inherited and are available in the superclass. And one more thing is the question is what we need to do. What we need to do if the method, if the method describe in the class, in the current class employee, maybe let's just call it employee, I hope you understand. In the class employee should be different from the method in the class person. So we have such situation that actually for example, here we just describe the person with all the parameters defined under the person object. So that's what we can do, and that's absolutely fine. But as we can see here, we have one additional parameter. And just to make it more correct, when we want to describe employee, then we can use the parameters which are assigned to employee class. And basically the question is, how can we, basically what we want to do, we want to extend the method describe, and this is basically what the subclasses are about. We want to extend something from the person. Of course, there's option that we can overwrite, not everything, but something from the superclass. But the most usual idea is that we want to extend. So we want to add something new, and that's basically the concept of inheritance. In the subclasses, maybe I will type it here. The main idea of the inheritance is we in the subclasses we want to add something more, basically extend the superclass. So that's basically the thing you need to basically to memorize, to understand that the subclasses have more. Basically, they have all the same properties that the superclasses have, but in addition they have some more parameters. Like in this case, we have all the things which are in the person class. In addition, we have one more parameter, qualification, and how we can extend the method describe. And here there's the word override comes for the first time today. It basically, when we want to override comes so annotation, and these things are called annotation, but override means that we want to override, rewrite, something this, but rewrite the method from the superclass. Yeah. So when there is annotation override, then we can have the method which is described in the superclass, and we can add some logic here. What we can do here? Basically, here we can create our new method. So maybe just a small something to show. This method is over. So here is the method, and we can see that this is just method. We just override it. So there's new object here. If we call super, using super, we can access the methods from the superclass. The implementation, more correctly, implementation of the methods in the superclass. So if we haven't changed anything, then the logic will be the same. And the same as if we don't override it. But what we can do, again, since we have option to add something new, we can add something new. So we can type system out print line, and then here we can write the level, yes, and then we can add this level, and just to make it, at the moment this will be 0 because we have not signed anything. So here you can see that I have line separated here. We don't need it here. Let's just oops, sorry. So we don't need this line separator not here. But just line separator. And that's fine. And here we can see that basically a new logic is added here. Okay, maybe let me just correct it a little bit to make it more precise. So now basically we can see that everything comes from the what comes from the superclass. It stays here, because we call super describe. So and here we just extend this method. We add something new, and this something new is printed. So maybe just to make it more clear, let's add another attribute, level, and this is basically how can we extend the constructor as well. And this application level, this level. So this is maybe a small extension of the constructor. We can extend we can override the methods, and we can use them in the way that we extend them. So what's the error here? And again, here we need to provide the qualification level. This is integer, let's be free. And now we can see that this parameter will be available and it is printed. And so that's what we can do. And maybe for CO. Let's finish with this extending, and then we have the break for the CO. Maybe let me answer the question from Natalie. The question is, could the class employee be the superclass for CO, for example? Yes, we can. That's also the option, and maybe I agree with you that that would be maybe more precise. In our case, what's the issue? Constructor. We need to. Maybe let's at the moment keep person. But it is possible. It is possible to extend it. At the moment, I just want to have the example when one class is extended, two classes extend one class. That's why I use the person, but maybe more precise would be. It is also possible, maybe in this case that would be more precise to extend CO, to extend employee on CO. It's also possible to extend employee or any other class. Why not? In this case, so if we extend for example, if we extend employee class here, it will look good that in the way that person is the superclass of employee, and the CO, and the employee is the superclass of CO. The superclass of CO. That's also possible. In this case, we have such tree, that we come from more generic to more specific. So I will type it in caps because that's the key quote for all for the inheritance. We go from more general to more detailed. That's the key. That's the key for concept of the inheritance. So now we have the person, and we need to extend we need to call the constructor the same way as we do for the person. So not CO, but CO, and here we don't have the qualification level. Okay, so maybe the last thing we will do, we will add some parameters. Maybe parameters would be so can be the parameter for the CO. Maybe let it be years at the position. For example, that's not something really meaningful, but I hope but the idea is just to show for you to understand. So here's at the position, just to make something different, and here we can add this parameter. I'll just add it as years, and I will assign it here years, and I'll call the method name. I will create the CO, and I will have the name to be Gates, for example, why not Gates. Then the age is, I don't remember, is 60, and years at the position 30, for example. Yeah, and so now again we can override the method. I will override the method describe, so it is available here as well. And the same as for the employee, I will extend it a little bit, and I will provide this information that CO works. Okay, maybe that's just simple years at the position. These years at the position. And if we print it, we'll see that all the information will be printed. And so we have one general class which prints the name, surname, and age. The class is person, and then for each subclass the implementation is different. Yeah, in this case it is extended. Again, we can override it as we want. We can add some. We can skip printing all these things. We can print something else, but maybe the most usual approach is that we extend. Yeah, and in this case we extend the class person differently. These two methods. Maybe I will comment it here. All three maybe the class says employee and CO extend the class person differently. That's the idea, that the subclasses can extend superclass differently. Okay, right now let's have the break, and after the break we will continue with the inheritance topic in general. Okay, let's move on with the inheritance, and so yeah, quickly we can see the presentation again. So we just started, then we moved to our example with employee and person, because I think that just that would be more understandable for the beginning. So if we just write code and then basically put all these elements together. Yeah, so now we can also check the wizard example. Yeah, all the same things are the same, and also the parameters are available. Then yeah, it also comes the example when we have the class which is extended from from another class, which is the superclass of another class. Yeah, so that's what I just talked about. This case, yeah, when if CO is the subclass of employee, then yeah, we'll have such tree, which at the top of the tree there is a person, and under the person there is employee, and under the employee there's a CO. That's also the option. And yeah, right here there's a thing called casting, but we'll talk about the casting a little bit later at the end of these topics. It's casting, but we'll talk a little bit later about it. And yeah, so in this case there's it's not mentioned about the objects here. Yeah, the objects are not defined. That's why I don't really like it, but okay. So imagine that we have wizard created, then there's the method. Punch face, and we can punch another dude. And then we can also punch the wizard. Yeah. Then we can assign some elements to the objects as well. We call the method. Okay, maybe yeah, this example is not so detailed. Methods are not defined, and objects are not defined as well. Yeah, basically, okay, what happens here? There's the method, which is called from wizard, and we can pass the object which is dude. Then yeah, so we check first. We run wizard class. Then if it's not there, so it is not overridden. So we have not overridden it. Then we go to the parent class. Then we search for the parent class. If it's not there, then we call for another parent class, and finally we find the method. Yeah, so here is the casting mentioned, but yeah, maybe I will talk separately about casting, because it's really important to understand what we can cast and what we cannot cast if we talk about the objects, the references. But yeah, we can use the casting, but again, here I would, before we start talking about castings, I cannot really explain it to you without talking about casting. Then let's skip it at the moment. So here's the schema. We have the wizard, then we have ground wizard, which is the subclass of wizard. And again, here you can see in this picture that we come from more general to more specific. Yeah, so the subclass should be more specific than the superclass. That's one of the examples. We have it. Yeah, that's what I already said. You can only inherit from one class. So we cannot inherit from two classes. That's In Java, that's not possible. It is possible in C++, but not in Java. In Java, you can extend only one class. Yeah, so that's because we can have such situation when both these classes implement the same method, and as we just discussed, we inherit all the protected and public methods from the superclass. So in case, just imagine if we have such option, like we can inherit from two classes, then imagine if both classes have the same method. In this case, Java compiler will not understand which method or implementation of which method we can use, and that's why Java does not use multiple inheritance for the classes. It is possible for interfaces, but we'll talk about the interfaces later. So yeah, inheritance in summary, we can class A extends class B. So that's the syntax. We use extends keyword. So it means that A is a subclass of B. A has all the fields and methods. B has all the public and protected fields. Private fields and private methods will not be available in the subclass. Class A can add its own fields and methods. You can, as we just discussed, you can add more methods and fields. But again, only one parent can be, only one class can be extended in the class A. Class A can replace a parent's method by re-implementing it, so we can override it. And that's what I mentioned. And A does not implement something Java searches orchestras, but yeah, that's something different. Okay, so here you can check the materials if you want. And yeah, this is basically a short introduction about inheritance. Let's code. So let's so now we discussed this one, and we already also discussed protected access modifier. Yeah, so basically protected is mostly used for the inheritance. Yeah, when we deal with the superclasses, with the subclasses, and the idea is we just want to define the attributes which we want to see in the subclasses. And so that's the main purpose of protected access modifier. To define the structure. When we define the private, we understand that the structure is that we do not want the attribute to be used directly, to be accessed directly outside the object, outside the class. So that's when we use private. When we use public, that just make access from all the places. But about the protected, we want to usually want to keep all the features private. Access modifier has, but in addition, we want to make it possible that all the subclasses also have these attributes, these protected attributes. They will be available in the subclasses, and that's basically why we use protected. So since we already discussed this topic, it's already discussed. The next topic is overriding. We already discussed it. We already started discussing it. Basically, yeah, the idea is that in the subclass we can override. Let's say the subclass. This is the subclass. We can override the method from the superclass. And that's the idea. So in fact, there's practically nothing more to discuss here. So basically, the main concepts I already described here. So just the simple concept. By default, all the methods are available. Yeah, all the public and protected methods are available in the subclass. If we want to change the logic, we use override. Yeah, we override the method. Eclipse can use control space, then find the method we want to override. Then we override it, and we just change the logic inside the method using the super keyword. We can access the method in the super class. Just one more thing to mention, that if we use this keyword, this is the object. This keyword, and this is the object. Okay, just to not confuse you, it is the object. Yeah, as you remember, if we use this, so this is the current object we are currently in. But super is not the object, and so we can use this as the object, but super cannot be used as the object. This is not the object. Yeah, so just not confuse. Yeah, we cannot just simply we can describe. We can define CEO, but person. It's just an example. Then we want to assign super. That won't work this way. We can actually assign this to person, but that's casting, and we will discuss casting a little bit later. That's also part of polymorphism. So yeah, just to not confuse you, that super is just the place where the implementation of protected and public methods are stored. So using super, we can just access the implementation of the corresponding methods in the super class. That's not the object. Yes, that's the object. Super is not the object. So that's about the overriding. So there's nothing much to discuss specifically here, yeah. But there is one topic to discuss. This overloading. We already used overloading. For example, not overloading, but the features of overloading. For example, when we talk about the array lists, yeah, you remember we have method add for the in the class array list. Yeah, we have method add, but actually we have two options. We can add the element. This will add the element at the end of the list, and we can use add and put the position where we want to place the element. In this case, we actually call the method with the same name, but we provide different parameters to it. And what does it mean? It actually means that method add is overloaded. So we overload method add, we provide different parameters to it. So basically, how to use it? First of all, we already used this approach for the constructors. Yeah, maybe that was for the officer, I guess. That was for the officer. We had two constructors. We have one constructor without any parameters. Then we had another constructor with with 5 parameters. And this is also called the overloading. We overload the constructor. So we have two types of the constructors. We can use one constructor or we can use another constructor. Okay, so that's the example for the constructors. Both of them can be used. And if we create the object with the parameters, then this method is called. This logic is called. If we don't provide any parameters, then just in this case nothing is called. If we create logic here, then add the logic here, then this logic will be called. But that's the key for the constructors. The same way we can do it for the methods. And we'll create the package. Overloading. And we'll create the class as an example. Thus, for example, we can create the class family. And inside the family class, we can maybe family. Okay, so yeah, we can add. Let it be family. So let's call the method. Let's have the method. So if there's the family, then new child is born, for example. Yeah. So there's family and born. Born child. Maybe let's add. Add child. Okay, so let's imagine that there can be so imagine that okay, I will use array list again. Use the array list again. Okay, maybe let me also create class child, and then I will quickly I'll create array list of all the childs in family, all the kids in family. I'll create the array list. And this is a simple example. If one child is born, then so the woman is pregnant, then the child is born. So in theory, one child can be born. In this case, we add one child to the list of children. One baby is born, and we add one. Another option is that twins are born. Then we can add. Let's add child, and then we can add two childs. For example, child. So yeah, now we can add two childs. we can add two childs. For example. So in this case, we have two methods with the same name. But with different parameters. Yeah, with different parameters. So here we have one parameter, here we have two parameters. And basically this is called overloading. This is called overloading. Yeah, in some programming languages there are such things like default parameters. In Java there is no such feature, but we can implement these default parameters in the code. And so, for example, if we have okay, maybe let's calculate something. Plus salary, for example. And yeah, and let's define the parameter base salary, something like that. Base salary. That would be, I don't know, 1,500 euros, dollars, or something like that. It doesn't matter. Okay, so here we have kind of base salary, and then yeah, we can have the method calculate salary. Public integer calculate salary. So the first option is that we don't provide any parameters. We can return base salary. Also, we can add parameter, like some parameters like could be bonus. Then the salary would be return base salary plus bonus. So what else we can have? We can have public salary, or public maybe addition, and just add percentages. So then we can use calculate salary, and add percentage. Then we call return base salary times that would be percentage, so 1 plus percentage. Something addition. So yeah. So there's one parameter, and yeah, that's point. If parameters are both the same, that won't be correct. Yeah. That will not be correct. Yeah. So you cannot. So this would not be overriding. So I will type the comment here. This cannot be done. because the method with signature, yeah, integer, one parameter, already exists. So what we can do here, for example, maybe let's do it for this method, because we can have start percentage, and in addition we can have the bonus. So I will comment it out, and I will add another parameter. So now we have three methods. The base method, when just return the base salary, then we have let's add this one as well. Then we have this method which returns base salary and the percentage and the bonus, and this one just returns base salary and the additional percent value. So let's test how it works. Example, but main method. So let's the class salary, and define the object salary, and let's calculate. Let's test what's the difference. I'll print all these values. So first of all, we'll print salary, then we'll print the salary and we pass percentage, what can be 5%, and then we pass the percentage, and we pass the bonus, so it will be additional value. So, and now we will see the result. So in the first case, the percentage will be divided by 100. So since we have percentage, that will be more correct if we divide it by 100. Yeah. So calculate salary. Yeah. Oh, okay. So let's. Oh yeah, that's because sorry, that's my bad, because yeah, I have not. Yeah, that's because we used integers then, and that's why we have such incorrect result. So what would be better if we use doubles here? Yeah, the problem now is that it considers this division as 0 because it compares to integer. I want to have doubles. Here I want to have doubles. And oh yeah, it's already a bit converted to double. And at the end I want to convert it to integer. Here's the problem. Okay, that's. But okay, maybe let's use doubles. That would not be the problem for us. That would not be the problem for us if we use doubles. Same is here. Same is here. So I would like to use doubles. And here I use brackets just to be more precise. Here I will also use the doubles now. And here as well. Just that one issue. And here we can keep integer. Okay, let's see. Yeah, right now the result is more precise, because there are decimal places and all the decimal values are calculated. So what we have here we call the method calculate salary 3 times, but based on the parameters we provide. Different methods are called. So in this case we provide no parameters. It means that this method is called this one. Yeah. So nothing is provided, then this method is called. If there's one integer value provided, so Java looks at the types of what you provide. If you provide integer, then Java does not look at the names of the parameters. Java looks at the type and the number of the parameters. So the positions of the parameters and the type of the parameter. So if you have one parameter, then you cannot provide string because there is no such method. Right? Yeah, there is no such method because we only have integer. But yeah, maybe in addition let's also add this option, just maybe to make it more understandable. We can calculate salary based on the name. Yeah, just why not? And here we can provide the name. And just maybe a silly example, if name starts with R, for example, then the salary will be reduced by 100 euros, for example. Something else, just return base salary. What we can do, we can return base salary. We can call different method from this method. Why not? And in this case, we'll see that if we provide the name, for example, Richard. Then okay, maybe I'll put it here again just to understand. Print up, salary, calculate salary, and here I'll provide the name. Yeah, so different method is called. Not the same as above. So in this case, the signature is we search for the method is the signature int. I'll get it this way. Calculate salary int. In this case, we search for the method with signature calculate salary and no parameters. So here we search for the method calculate salary and the parameter string. And here we search for the method with the parameters integer and integer. So 2 integers are here. And based on the parameters, based on the sequence of the parameters we provide, the different methods can be different. And also, if you define the method string integer, just maybe one last example, calculate salary, the calculate salary, then name and age. And let's add some logic here. Just something like that. And you can also declare the example that the sequence of the parameters is different. Yeah. So different sequence of the parameters provided. then the method will be considered as different one. So we can override the methods also in the way that we just change the sequence. Yeah, change the sequence of the parameters. Just something. Let's just change it this way. With some logic here, you can define your own logic here. But the idea is that the signature of this method is calculate salary integer string. Signature of the method above is string integer and signature integer string is not the same as signature string integer. So if the sequence is changed, then this is considered as different signature. With the different with different sequence. So yeah, that's what about overriding. We will not discuss in details more about it. We'll have the examples. We already had lots of examples with the overriding. One of the examples is also system out print method. Yeah, as you can see, there are different parameters you can provide to the method print. So it means that the method is overridden or overloaded. Yeah, overloaded. So, but in case you have any questions, you can prepare it for the next time, obviously. Then I will answer these questions next time on Wednesday. But we will move on. Yeah, after that we'll move on with other topics. And so we'll have abstraction next time about interfaces and abstract classes, and also we'll finish with polymorphism topic by talking about also casting, which is also important part of the object-oriented programming. Okay, for today I think that's it. Thank you for your attention and see you on Wednesday. Bye.